Now, how do we find zeros of polynomial functions? Let's look at this first example. That's a polynomial function. F of x equals 2x minus 3. How do we find the zeros of this polynomial function? We set 2x minus 3 equal to 0. So we are trying to find values of x for which 2x minus 3 equals 0. And we can do that by solving the linear equation. Linear equations are easy to solve. And we get, on solving the equation, we get x equals 3 halves. When we plug in 3 halves into the function, we get 0. So that's how we find a zero of the polynomial function f of x equals 2x minus 3. Now what if we got f of x equals x squared plus 5x plus 6? How do we find the zeros of this polynomial? We set x squared plus 5x plus 6 equals 0. If it is factorizable, we factor it and then solve for x. Here in this case, we get x equals -3, -2. If we plug these numbers back into the function, each time we get a 0. So we found the two zeros of the polynomial function f of x equals x squared plus 5x plus 6. So it's a quadratic equation that we had to solve. What if we were not able to factor the quadratic function? Then in that case, we would use the quadratic formula and solve it. So there is a way or a method that we could use to solve the equation. But now suppose we got f of x equals x cubed plus x squared plus x minus 3. Where do we begin? There is no single process that we can use to solve this equation. So in this case, we'll have to find the possible zeros of this function using the rational zero test. And what does this rational zero test say? If we have a polynomial function, so this is a polynomial function, then the possible rational zeros of f are p over q. So that's a rational number p over q, where p is an integer and q is an integer. And p in this case is a factor of the constant term. In this case, the constant term is a0 and the leading coefficient is an. So p is a factor of the constant term, which means it's a factor of a0, and q is a factor of the leading coefficient an. Now, in this example 3, the constant is -3 and the leading coefficient is 1 because it's just x cubed, so it's 1 times x cubed. So the possible rational zeros, these are only the possibilities, and they're the rational zeros. Rational numbers are in the form p over q, where p is an integer and q is an integer. And we need to make sure, of course, that q is not equal to 0. So the possible rational zeros are p over q. And p is a factor of the constant term. The constant term here is -3. A factor, a number that goes into 3 is called a factor into -3. So both +1 and -1 are factors because 1 or -1, both 1 and -1 both divide -3. And +3 is also a factor because 3 goes into -3, -1 times. -3 is also a factor. So in the numerator, we have plus or minus 1 or plus or minus 3. See, these are the possibilities. Now q is a factor of the leading coefficient. In this case, our leading coefficient is 1, and factors, the only factors of the leading coefficient 1 are plus or minus 1. Okay, so now we look at all possible zeros, and the zeros are plus or minus 1 divided by plus or minus 1. What do we get here? So we have plus 1 divided by plus 1, plus 1 divided by minus 1, minus 1 divided by plus 1, plus 1 divided by plus 1. All possible combinations of plus or minus 1 in the numerator and plus or minus 1 in the denominator. So we have either 1 or negative 1 as possibilities. Next, we take plus or minus 3 in the numerator, and of course the only possibilities in the denominator are plus or minus 1. So it could be plus 3 over plus 1, plus 3 over minus 1, minus 3 over plus 1, plus 3 over plus 1. So these are all possible values in the denominator and numerator combined. So this would be 3, negative 3. These are the only two possibilities. Okay, so let's look at all possible or just possible zeros of the polynomial x cubed plus x squared plus x minus 3 equals f of x. So these are the possible zeros. So what does that mean? Now, it doesn't mean that all 4 numbers are zeros. Obviously, all 4 cannot be zeros because it's a cubic polynomial and we can have at most 3 zeros. So at least this gives us the possibilities. So now we're going to check. Let's see if we plug in a negative 1 into that function. So the function is negative 1 whole cubed plus negative 1 squared plus negative 1 minus 3. So what we've done is we've plugged in negative 1 into the original function f of x equals x cubed plus x squared plus x minus 1. So we get negative 1 plus 1, negative 1 again, minus 3. So obviously that's not equal to 0. So negative 1 is not a 0. Right? So next we plug in a positive 1. So positive 1 the whole cubed plus positive 1 the whole squared plus positive 1 minus 3 is 3 minus 3, which is equal to 0. So what we've done here is we've found that 1 is a 0. Okay, so this is how you can find the zeros. Okay, so if there are only 4 possibilities, it's easy to just plug in the numbers and check which numbers make the value of the function equals 0. In this case, we plugged in 2 numbers and we can always plug in the other numbers as well. We plug in the numbers and we see that negative 1 is not a 0. 1 is a 0, and we can try the other 2 numbers as well. Okay, so this is how we find the zeros, at least one of the methods that we can use to find the zeros of polynomials of degree higher than 2. Now another way to check if there is a 0, if any one of these is a 0, is by using your graphing calculator. So graph the function f and then look for the x-intercepts. Make sure that the window of your graph includes these numbers: x equals 1, negative 1, 3, and negative 3. So make sure it includes these numbers, so that way you can see where it crosses the x-axis, and based on that you can try to figure out which of these numbers is a 0.